Hi, today I'm going to show the different components of a multimeter, which is this machine. So I'll show you the different components of this machine using some materials. So I'll tell them materials required by doing each of the components. So multimeter consists of a machine like this and two lobes. So one is positive and one is negative. So here you will see three holes. So this is the positive one and this is the negative one. It won't be marked, but here COM means positive and the second one is negative. The third will be used for a component, which is I'll tell you later in the continuation. So now this is the positive, so I'll connect the black wire is the positive wire. I'll connect it to the first one. The second one is the second terminal, so I'll connect it over here. And I'll start showing you from the buzzer symbol over here. So you have to drag this scroll thing and take it to the buzzer. So this buzzer is used to indicate if any substance is insulator or a conductor, or it also shows the if you have a broken circuit, if electricity is flowing or not. So like that it will show. So I have one insulator type thing and one conductor. So it's a pencil. So when I take this pencil and when I keep, you'll see that no sound comes out of the multimeter because it's an insulator and no current is flowing. So if you want to see that if current is flowing, so here current will be coming and here it will be coming. So when you connect, so you see here a sound. So this is the thing for showing if it's a conductor or an insulator. So this is not giving any sound, so it is a insulator. So I have a metal hairpin. So when I connect, still it's not coming. So you can try with any other, like a safety pin. So sound is coming, that means it's a conductor. So it's a conductor, so sound is coming. So this is the first component, that's the seeing the insulator and the conductor. So the next is the resistance calculator, which is over here. So first turn it to the 200. So there are many options, so we'll see each of them. So I have a set of resistors over here. So these are the set of resistors. So it will show that how much amount it resists. So first I am keeping in the 200 mark and I am calculating. So it shows about 1 because the number of resistance will be more, but I am set it as at 200, so it will be more. So we'll do it with another, then we'll increase and see. So the number shows 1 over here. Next one too shows 1, that means the resistance will be more than 200 ohms. Next also seems like it's more than 200 ohms. So this is less than 200, so this is also more than 200 ohms. So it shows 1, so this is also less than more than 200 ohms. The last one, so all of them are 200 ohms, so we'll have to increase and see. So I am increasing the ohms to 2000. So now we'll check everyone. So the first resistor shows that its resistance is about 200 and it's fluctuating. So it's about 220 ohms. So the first one is 220 ohms. The second one is, it's slightly more, we'll keep it for the next one. So this is also slightly more, we'll keep it for the next. So this is about showing 1000, it's fluctuating. It's 900 and it's about 990 ohms. So this is 990 and this is 220. So this one, so this is about this is about 470. So about 460 ohms, and the last two will increase for 20k ohms, and we'll see how much it comes. So it's still more than 20k. This is also more than 20k. Then we'll increase to 200k. So this shows about 68 ohms. I mean 68 k ohms, and this one is about 33 ohms. So we calculated all the resistant numbers. So next will be the volt calculation of a circuit. So in a circuit, how much in a battery, how much volts will be running. So like that we'll be calculating. So we have a 9 volt battery over here. So the first one, so you'll have to keep the battery over here and connect. So I'll keep it at 200 meters first. So it's more, so I'll increase it. So it's still more, I'll increase it to 20. So now it shows about 7.72, which is almost 8. So it's about 8 ohms. So it will be about 9 watts. So it shows here about 9 watts when you keep it. So it shows 9 watts. Can't show you. So this is 9 watt battery, and this one this shows about 1.59 or almost 2. So this AA battery is about 2 watts or more than that. almost 2 watts. So this is the second component of calculating watts in a battery, or you can calculate with more bigger batteries like the battery in a fridge. So next will be the ampere, that's the calculation of a current. So for calculating the current you will need a circuit. So for that I'll make a circuit over here. I'll take 2 wires and make a circuit. So I'll connect the positive to the positive and negative to the negative, so the light glows. So to calculate that how much current is is flowing here, we'll have to change some setups in the multimeter. So we'll have to take the red outlet and connect it to this wire. And now take this wire so I'll have to connect this red wire to this red wire. So now when you connect this black to the terminal, so you'll see that the light is glowing. So before that you will have to change the setup over here. So I'll keep it at about 10 amperes or 10,000, I think so. So I'll keep it in the 10 mark over here, ampere. So now when you connect it, you'll see the number over here. So it's showing about 0.20 watts almost. So this is the watt number of 9 watt battery. So it gives about 0.20 amperes. So you keep it to the 10th mark. So next I'll try it with this AA battery. So when you connect it, so the terminals will change. So now this will connect it to the positive terminal over here. And then next wire you will connect it to the over here. So when we connect it over here, here it should connect properly. So still it doesn't glow because there is some fault in this battery. So you can try this with many types of batteries. Now I showed it with a 9-watt battery. It's not working with a AA battery. So these are all the components of a multimeter. Thank you.